to day 2 of the second annual Encryption Consulting Conference. Our next speaker is Thomas Gustafsson, Chief PKI Officer at Keyfactor. Thomas will present on operating PKI in the new Zero Trust multi-cloud era. A bit about Thomas: he has an MSc from KTH in Stockholm and has been researching and implementing PKI systems since 1994. He is the founder and developer of the open source enterprise PKI project, EJBCA, a contributor to numerous open source projects and a member of the board of Open Source Sweden. As a co-founder of Prime Key, now Keyfactor, Thomas is passionate about helping users worldwide find the best possible PKI and digital signature solutions. Please welcome Thomas.
My name is Thomas Gustafsson. I'm the Chief PKI Officer at Keyfactor, and I've been working with PKI for quite some time now. Today I will talk about PKI operations, which is an old technology, which we've been using for a long time, and how to do it in a modern Zero Trust multi-cloud era. First, I like to start with mentioning that why things are changing when related to PKI. It's because back when I started, cryptography was something that was for some special applications and not for everything. But today, cryptography is not a commodity anymore, but it's an essential building block for digital trust, and all the applications that we rely on every day on the internet relies on cryptography. So if that falls apart, everything that we believe in today or use today will also fall apart. And some drivers for this change that has happened in the secured or PKI space in the last decade or so are, for example, Sarbanes-Oxley, which has been around for a number of years by now. But it started to mandate that developers does not longer have right access to production systems. So it's more, there's a lot of this separation of duties regulations or requirements that have been introduced. And another one is cloud compute, where dynamic workloads that can be turned on and off at will, which has some new challenges for things like PKI, which where you just can't put something on a server anymore at one time and then expect it to be there for a long time, because the IT environment is much more dynamic. And then we have the DevOps revolution. A long time ago, there was clear separation between development, configuration even, and operation, and there should be different teams that did different tasks. But it seems, or we've quickly figured out that that was not really the most effective way to do things, and that's not how things were done in practice. So nowadays things are much more blurred between agile development and operations, and it works more hand in hand together to develop at higher speed. And of course, digital transformation of the society is something we are all experiencing, where mobile and browsers are storefront, and we do everything online, and we don't have to visit places physically as we did before, but can handle anything from home. It requires a lot of security to be able to do things that we never did over the internet before. That brings us into Zero Trust, which is a buzzword that probably most of you have heard about. But in my context here, I will take it to mean what here in the third bullet it says perimeter less security. It doesn't mean the perimeter is going away. The perimeter will probably always be there. We will have firewalls and VPNs and network segmentation and DMZs. So this is never going away. So we're going to have a perimeter. But the perimeter is just one level of our defense in depth strategy. So with that defense in depth strategy, we have to assume that all levels of it can be broken. That means that we have to assume that the perimeter, even though it's there, is broken. So we cannot implicitly trust things that are within our perimeter, but we have to always verify and not trust anything by default. So that also drives a lot of need for additional security. And if we look at the State of Machine Identity report, which the Ponemon Institute have done for us a number of years, we see that zero trust security strategy has risen up to become the most important trend driving the deployment of PKI keys, certificates, and other secrets. So where 55% of respondents say that zero trust is the top trend driving the future further use of PKI. And we see cloud-based services, which was previously the top, being the second now. But keep in mind that cloud-based or moving to the cloud is not seldom one piece of a zero trust security strategy. So these go a little hand in hand. Which is something that is also interesting here is that a majority, 65% of respondents, are concerned about the increased workload of IT staff, actually, and risk of outages, which is caused by PKI certificates, or because there are more TLS certificates out there and they have shorter lifespans. So this drives both workload on the organization and risk of outages. So all this works together, to create an explosive growth of machine identities that we have seen in the last couple of years, and that does drive new challenges and risks that are beneath the surface that are not always obvious, but that organizations run into after a little while. Can be scale and operations and outages and things like that. So going into a little bit about the new use cases that this presentation is about. So we still have enterprise IT. That is a very classic use case for PKI. It has been around for decades, giving certificates or identities to servers, humans, and things like that. But this kind of traditional piece of PKI is also seeing an increased burden from the organization to be more flexible and more scalable with more internal certificates and new products and business units, etc. So the enterprise IT is modernizing to adapt to a new way of operating internally in organizations. And then we have completely, or rather new, use cases such as in the manufacturing. If an organization is manufacturing things, can be cars, can be wind turbines, can be comfort controllers or something small, security cameras, something like that. There are increased requirements of securing devices end to end, which for manufacturing commonly means to put initial device identities on the manufactured devices already in the manufacturing facility, which is a rather new arena for PKI and where people are not so used to operate PKI as within enterprise IT. And IoT has been around for many years. Everyone has talked about it. And in this context, it's been operating IoT. So after it has left manufacturing, it needs to be maintained over the complete life cycle of devices with over-the-air updates, security updates, and of course, secure communication, which in many cases requires PKI. Something that is, say, a rising star in the State of Machine Identity report I mentioned before is the DevOps revolution, if you call it like that, where which has put a lot of focus in the recent years on the software supply chain security and securing all different steps from development and coders into production and deployment, and all the security that is needed along this whole supply chain. So there's quite a lot of increased usage of PKI in this space as well. So this slide I have used before, but I think it's important, at least for me, to highlight a little bit that we have all these different pieces of PKI, and I also talk a lot about PKI consolidation in different contexts, where you, for example, in your corporate IT, you have dispersed PKI systems a little here and there, which you don't have full control over. So one way there is to consolidate different PKI systems into a single or a couple well-maintained, securely configured, securely operated systems. But this will never be possible for all cases. So there are many reasons, some very good ones, to maintain separate PKIs. I call them PKI silos because they are completely separate for different use cases. For example, in manufacturing, it may have to reside on another site. It may have online or offline requirements and things like that. So there are many good reasons why some PKI silos will always remain in your organization. But what you want to try to achieve is to have an overarching PKI governance, which controls both, say that the PKIs are operated in a secure way and an efficient way, of course, for your organization. So you save workload on your staff, and that hardware security modules are used where needed, and things like that. So this overarching PKI governance, I call the hybrid approach for modern PKI. So you can maintain control over many disparate PKI silos, and of course ensure that you lower the risk of unexpected outages, which might otherwise adversely, negatively impact your organization. So if we move into technology as the next part of the presentation, when we talk about cloud and multi-cloud and things like that, we often refer to applications running as microservices. And in this microservice world, we make use of many tools, such as automation tools such as Ansible and Helm, Kubernetes to run containers, vaults to protect secrets. So this also applies to PKI. I divide it into two parts here, PKI as microservices or PKI for microservices. So if we look at them more closely with PKI as microservices, I mean to run your PKI in the cloud and containers. If that's the way your organization is operating largely, you want to have your PKI operated in the same way to keep it efficient. And you want to have automated deployments in order to effectively manage, deploy, and control different PKI silos. When we talk about PKI for microservices, we talk about the workloads for your business application that needs keys and certificates, automatically injecting keys and certificates when they are needed, perhaps at deployment, protecting secrets, of course, and just giving the PKI services to containers and service mesh that they need. A third leg I commonly talk about is integrity protection of code, which is another important piece, especially in the DevOps space, where integrity protection of code signing, and container signing ensures that the code running or updated are authentic, and that code running in a container cloud is the intended code. And of course, automation, continuous integration. But we'll focus on the first two here in this session. So first, PKI as microservices. I've used this slide before as well, but it works well as a good ingress to the next slide. So this slide was originally created by Siemens, who demonstrated how much they could gain from automating PKI. So when we talk about zero trust and multi-cloud and everything, we actually talk about the time we are in, which has a lot of higher speed of development for most or very many parts of the organization. There's new products being developed, there's new business units coming in, there may be mergers and acquisitions, and everything should well, we want everything to be managed as efficient as possible, and that also needs PKI needs for these different products, business units, etc. So before, say in the classic way, which is still used, of course, and still good in some cases, you install a new PKI when it's new, that you deploy operating system, install applications, configure them, harden everything, set passwords and permissions to make everything secure, and hope you don't forget anything. And it can take anything from a couple of days to weeks, or I've even heard about months, to set up a new PKI. And that's for a business unit that tries to develop a new product to get to wait, weeks or months for a PKI to start testing is too long. In contrast, if you automate this as infrastructure as code, with the parameters in a central place for each environment, when you need to set up a new test environment, you can create a new set of configuration parameters, set them to the new business unit or product or whatever it is, and then run a single playbook in this example using Ansible, and have a new test environment up and running in 10 minutes instead of days or weeks or months. So that means every developer in your organization can have its own, his or her own test environment for PKI when they develop new products, etc. So that doesn't only help the PKI department to manage things, but it helps the whole organization to move quicker and be more agile for any business unit or product that uses PKI. Taking it to the next level is, of course, automating container deployments. Moving from using virtual machines to containers has been I would say, quite strong trend for the last couple of years. And if we had Ansible as an example in the last slide, infrastructure as code for container deployments, Helm, also YAML-based, is a very, or maybe the most popular tool currently. So running a set of Helm charts, you can deploy a full PKI with load balancing and highly available in a Kubernetes, can be an internal Kubernetes cluster or external cloud, where your PKI database and hardware security module runs as separate container services. What the slide shows here is that once up and running, you have an ingress that points to a cluster IP, and the PKI service runs as a deployment with a pod in Kubernetes. And there you can configure in your Helm charts to say what scalability aspects you use. So you can configure to have at least X instances running at all times, say 3, for example. That means that when there's low load, you have 3 instances running for high availability. But if the load increases, it scales up to more instances to handle increased load. And when the load drops down, it retracts again to minimum 3 instances. So this makes use also the PKI system, which otherwise can be say resource constrained, to be vertically and horizontally scalable, just as your other business applications. So looking at PKI for microservices, then it works very similarly. If you use Ansible or Helm or virtual machines or containers, doesn't matter. You often want to automate your normal application deployments as well, to have it reproducible with controlled secrets. If your application uses HSMs, they can be automated, different orchestrations framework. And it can be a natural part in your DevOps tool chain. But then when your applications are deployed through a playbook or similar, or Helm chart, they can, when they are deployed, get the machine identities, be it for TLS, be it for digital signatures, or any other purpose your application use keys and certificates for, as they are deployed. And then they are, automatically, of course, And then they are deployed, and when run, it's uses authenticated and secure communication for everything. And an additional benefit when you deploy your applications, and including the security PKI they need in this fashion, is that you have your infrastructure as code, which is also documentation, you can say, for compliance and audits. So when you need to show your audit to someone or teach new staff about the security, you have the infrastructure as code as quite good documentation, and it's reproducible. So when a person leaves, the knowledge doesn't live with that person, but can easily be transferred to the rest of the team. And the last part, I will talk a little bit about the agility needed for deployments in this new time, agile times that we live in. First, a little bit about deployments where best suited. We all know there's a kind of a drive or a trend is a move to the cloud. So of course, also security and PKI and digital signatures have to live in the cloud or as a service, software as a service. But on-premise is still, if not half, or if not more than half, at least half of deployments for many good reasons. Might be extra high security environments, maybe online, offline, or maybe just organizations that run on-premise software. So there's a need of hybrid deployments where maybe some parts, say high security root CAs or issuing CAs for internal applications, live on-premise, while issuing certificate authorities for applications that live natively in the cloud are in the cloud or as software as a service, or validation authorities, OCSP responders that need to be globally distributed. So this type of hybrid deployments is something that we see more and more now as organizations scale out on all aspects. This example diagram is how a cloud quite scaled deployment can look in a public cloud. In this example is Azure, but it can be any other public cloud. So if you run your PKI like this and need to connect a new product line or a new business unit, it can come in even through something like the marketplace, and it routes and set up a new pod which is managed in Azure Kubernetes part, or Azure in a Kubernetes cluster there, with all the different PKI scaling with the scalability needed for this business unit or product. And it also makes use, of course, of a lot of different, say, built-in features of cloud providers, such as load balancer, caches, queuing systems, monitoring, of course, and log collection. So you can make use of a lot of these built-in tools to make the very scale-out deployment very efficient. And to the right there, you see provision for each customer as well as subscription is the database for this specific, be it business unit or product line, where in this case a cloud provided RDS database, which lives then with a primary database in one availability zone and standbys and replicas in another availability zone. And of course, make use of cloud providers, DNS services, and hardware security modules such as Key Vault and MHSM. And finally, talking about hardware security modules. When we move to especially multi-cloud environments, we have a little quite challenging phase with hardware security modules. We're used to, say, for on-premise solutions, use on-premise HSMs, which use the PK611 API to access them. Now in all the major cloud providers, not only the ones listed here, but also others. There's a kind of a slew of different hardware security modules, such as AWS KMS or Cloud HSM, which have different FIPS levels. The same with the Azure Key Vault or Managed HSM, which are accessed through REST API, which have different, the difference between Key Vault and MHSM is the FIPS level. And also Google has the same with their KMS, which is accessible through a REST or PKCS11. And not to forget the classic HSM vendors that have also set up cloud HSM services such as Dpod, Fortanix, Utamaco, and Cypher, etc. So how to think when you want to use hardware secured modules from a multi-cloud environment, if you want to run your workload in multiple clouds. So one kind of easy way is to use an external cloud HSM, because then you are not depending on the specific cloud HSM of the cloud providers you are using, because typically you cannot use the same keys in you cannot generate keys in an AWS Cloud HSM and move it to a Azure MHSM. So it's just not possible unless you create an extractable, which is the next topic. So one way of say getting rid of this challenge is to use an external Cloud HSM, which can be used from any cloud provider and which keeps your private keys, the same keys, accessible from all clouds. Then there are, of course, some drawbacks. You have one more provider. You don't have a single provider, and you have to consider your architecture for points of failure, etc. But it's a good choice, of course. The second one, which you see a lot about now, if you read documentation, is bring your own key. So that means that you can generate the keys not even in any of the cloud providers HSMs, but somewhere else, and then you can import them to whatever HSMs you want, be it KMS, Cloud HSM, MHSM, GCP KMS. The downside there is that you have to generate keys which are extractable, and then extract them, wrap them with a symmetric key, and then you can import them in the cloud provider HSMs. So generating extractable keys is something which may not be okay under every say audit scheme that you operate under or under all regulation. It's also another complication or another process that you have to do for every key that you generate. So if you generate a lot of keys, it's quite clumsy. If you generate keys very rarely, it's might be okay, especially since you can leverage, of course, automation to help you with it. One thing that can help you with that is there are some products on the market for which act as like an HSM proxy, which sits as a layer between your application and the various HSMs from different vendors and generates these extractable keys, which can be imported in many different HSMs and then used as a single HSM, or the same keys reside in all HSMs. So these are kind of three different strategies that you can leverage to accomplish using cloud HSMs in a multi-cloud era. Of course, the best thing or the most simple is maybe if you are able to run your application so that the same keys doesn't have to be used in each cloud. For example, if you have a common root certification authority and only need to have different sub-CAs in different clouds so they can use different signing keys and don't have to use the same signing keys. And of course, automation will be there again and help you with all this at the scale that is needed and the rapid change and evolution of PKI that is asked for today. And that was all I had. Thank you for listening to this presentation of using good old trusty PKI technology with new cases in zero trust and multi-cloud era. Thank you.
Hi there. Hi, Tomas. How are you?
Hi, I'm great. How are you?
Good to see you again. Thanks for your presentation.
Well, thank you.
I've got quite a few questions that have come in for you. So I'll start with this one. If I am using cloud, why should I be using on-premise HSM?
There is actually some use cases, and that would be regulation or compliance driven. So there are some use cases, for example, in EIDAS use cases, where you need to be able to demonstrate physical controls of your keys, which means, yeah, you have to have the auditor look at your HSM. And then we have seen cases where people have managed to run the software in the cloud, but the HSM on premise. It's maybe say architecture or technically not the nicest, or maybe nice is not the right word, but not the most efficient deployment, right? So I totally understand the question. So probably unless you're under such regulatory constraints, you probably wouldn't do that. But there are
Okay.
such use cases.
Okay, thank you. That makes sense. For HSMs in a multi-cloud environment or where you may want to migrate clouds, what do you think is the best solution?
We do see many people using an external HSM provider, such as Depot, Fortanix, etc. And this definitely works pretty good. So it is a common approach, right? But another viable strategy, which I always kind of think about and want to discuss with people, is to use the inherent, say, PKI architecture of having a root CA with multiple issuing CAs, where you can leverage kind of the nature of PKI in a way that you can use multiple keys simultaneously. So you can have issuing CAs which use different keys and maybe in different clouds, which makes your solution really resilient. It does put some, say, not constraints, but it requires the relying parties to be able to handle kind of what I would still consider a fairly standard type of PKI hierarchy with different CAs, but they chain up to the same trust anchor. But that, by doing that, you can really get resilience and multi-cloud, where if one cloud goes down, you can still operate the other ones for everything, even key generation and things like that. And of course, you shouldn't count out to bring your own key. It may be great for some use cases, but typically for PKI, it's not considered really a good practice policy-wise, and definitely not allowed under some audit schemes. But it always depends on what exactly you're doing, and if you can decide completely on your own what your policy says.
Okay, thank you. I have an attendee who has asked, does Keyfactor provide a supported ACME agent other than CertBot and Cert Manager?
Let's see, Cert Manager and CertBot. So yes, we also support, now let's see, what are the names? There's a PIAC, I think. There's some other, say, Acme clients, one Java-based, and see if I can quickly see the responsible. Now I don't remember the names, but there's here we are. There's a third part is Acme4j is a Java-based one, and there's actually a simple, plain script one, which is called acme.sh. So we tested with a couple of different Java clients out there. And of course, the benefit with Acme is that there are multiple clients out there, which are all, free and have their benefits and drawbacks. So we try to test and be compatible with a number of them.
Okay, thank you. Here's another question for you. Why automate? Isn't it easy for developers to set up a test PKI with free tools and start testing?
Of course, yeah, there is. And especially, you do something like OpenSSL or write a script and things like that. But there is, of course, always a risk that these simple tools end up in production, which is against, security policy and best practices, not using HSMs. There is also this thing that details do matter, or the devil is in the details. So if your test environment is not production-like, might be using the same certificate fields, naming structures, APIs and protocols and such. There is a fairly large chance that when you move to production or pre-production, there might be some issues, which would have been more cost-effective, to handle from the start in development than try to fix in the end. So it can be a huge time saver to have everything as production-like from the beginning as possible. So this is something we hear from, say, large product organizations.
Okay. And then I have one more question here. What are some of the biggest use cases for PKI that organizations get into when working on zero trust initiatives?
There's definitely more than I even know about, so maybe just some that I hear about. So of course there's generic TLS certificates for every server communication needs TLS, even in the DMZ. And as an example, every database connection will have to use TLS, every API endpoint, etc. And there are definitely many servers that didn't use TLS certificates before, for example, for the database connection, but that will need it now. And getting rid of static secrets and have more multi-factor authentication in server-to-server communication. And in these cases, also client certificates are leveraged. Just one very, not hyped, but popular example right now is service mesh with MTLS between every container that you deploy. And another use case is the supply chain, or hardware or software supply chain. So for specifically product manufacturing companies, now it's becoming more and more that every product manufactured have a device identity, or even components within a larger product. And different companies call these device identities different things. Or if chips are manufactured in one place and the device is assembled in another, there is a hardware supply chain that needs electronic automated verification in every step. And of course, by now the infamous software supply chain with the code signings, where developers are signing every commits. So there's new keys and certificates needed, and they are on a much larger scale than it was before. And these more higher security practices are moving out from maybe just specific environments into mainstream. So that's when we see a large growth as it moves into mainstreams, things that has been used for a long time, but maybe in specific high security places.
Great. Thank you, Thomas. Thank you so much for your presentation and for joining us live. I know it's probably late where you are, so thank you. And if any other questions come in, we'll get in touch with you. Thank you, Thomas.
Absolutely, do so. Thank you very much.
Thank you.
See you.